Greetings, neighbors. My name is Mark Kidder. I live in Wildwood at North Point, and I'm about to show you a system that's got a bit of attention since I posted something late on Friday night about an alternative generator system that uses a whole house distribution concept with a portable generator. So I'm hoping this is going to be of some help to you. I want to thank my stepdaughter Chloe to help video and hopefully stitch this together so it makes sense. Let's take a look at the generator I have. I'm going to point to this. This generator is 12 years old. It's a circa 2009. It arrived to me as a gasoline only generator. Then at that point, this kit here is a conversion kit that ultimately converted only gas generator to natural gas and propane. And now it's connected to a natural gas line. And this makes it useful because you don't have to refill your tank with gasoline while the generator's running, and it can be kind of dangerous to do so. In addition, gasoline, as most of you may know, is problematic in that it can varnish over time and be problematic and give fits with your carburetor when you're trying to start your generator if you haven't started it every month as recommended. So natural gas burns clean. It also allows for clean starts. I've went as many as 4 years between starts and never had a problem starting it. So I'm going to show it connected, and it's connected right now to natural gas by way of quick connect. I'm going to show you how that works. If you're not familiar, similar to air compressor, this one's a little bit bigger. This is a quick connect hose. You connect it back, you slide back the sleeve, and simply put it on. Now it's connected by gas to this to the gas meter. So let's follow this hose around, and hopefully you won't get too dizzy as we walk slowly around the house to show you the connection for the gas meter. So the hose comes around, and I'll have my dear stepdaughter focus on this for a second. Here's the gas meter. I had a licensed plumber install this T here into the gas main line, and here's a valve that was installed that basically open and close service to the quick connect. Similarly, you saw the same quick connect and operates the same way here to quick connect the hose. So that is how you get gas from the meter to your generator. So let's go back around. Follow me, we'll go back to the generator. And we'll get it to start up, and we'll generally show you how this thing starts up and how, once I made a fresh connection like this, just on the other side of this, be hard for her to photograph, so you don't need to try, but on the back side of this, there's a little primer button. I press this with my hand and finger to basically remove the air from the chamber that may have been introduced when I removed the hose. And then I put, in this case, it's a automatic start on button, and then I hit the. Any generator we would provide would be electric start as well, and with a float charger that you just keep it plugged in to keep the battery topped off for power. So this is how you get the fuel source to the generator to power the generator, instead of having to hard line a natural gas plumbing connection like you would do with a whole house generator. This hose is portable, the generator is portable, and the portability of this unit is kind of valuable as well because I can tuck it in my garage, under my bench when it's not in use, and when I need it, I can take it out. I can also bring it to people who otherwise may not have power in a bind. And if I need to do that, albeit I've never run gasoline through it ever, I never have, I could easily just pour gasoline into this generator so it would be with yours, and you'll be able to take it anywhere and as portable power when you need it. Also, should you move homes, which I did twice in 12 years, the generator, the hose, power lines come with me, as it would be a little bit more difficult to do that with a whole house generator. So now we got power to the generator, assuming we start it up, and here's the electric connection. And in this case, I have a 30 amp service, and this is the plug I have, 30 amps. But however, in the case of going forward, we would be using 50 amp plugs for anything we would sell because that gives you greater capability. So this is a 30 amp service. The cord for this distance that I needed for my generator has been properly sized with the right gauge. Come follow me, if you don't mind. Follow me to the connection in the wall. It's kind of important for me to say that what you're seeing here looks pretty simple, and it is. Once you create the right fittings, convert it, put the hoses together, put the line together, it's really easy to connect. It takes a little thought and some calculations to get the right size of hose. In case you notice this hose I use, it's a fairly big hose. This required a larger diameter hose with larger fittings to run a distance of 75 feet to bring the right amount of fuel to the generator. The conversion kit's a little bit tricky to install as well, and can, if not installed properly, your generator won't run properly. So, and then here comes the electric cord. So let me talk, assuming it's in operation, I think it might be better. I'm gonna stand on this side maybe for you to see. Power comes in, so how do you get power from the generator to your breaker box? This is a cord that sometimes is affectionately known as a suicide cord when not configured properly, because most plugs are male in your hand and female in the wall, which is fine. In this case, if you had a male plug hooked up to a generator that's pushing 7,200 running watts, if you brush it against you, it becomes a suicide cord. In this case, this is a safe way of powering your house without fear of electrocution, and that's what makes it safe. So this box is normally used with an RV type hookup, but ultimately is wired directly to my breaker box to provide power, and use my breaker box as the means of distributing power throughout the entire house at any time. So I can put this back on fast. Okay, just a slight twist. It's now connected to the generator. Now at this point, the master electrician gets involved, which is not I, who ultimately wires this box in. On the back side of this wall, there's a wire that comes straight up to this breaker, which is dedicated to to allow the generator to feed power back to this breaker box. What you see here, so Chloe, let's step back for a second real quick. This is the key components of the system. And one is you need this reverse plug that I showed you earlier. This is key. This is maybe the most important part of the system. This is called an interlocking plate, or a breaker interlock, which ultimately means you can't turn on your generator power unless you turn off your main breaker power. So in this case, I'm gonna do this. I'm gonna turn my power off and I'm gonna demonstrate it. This plate is installed by a master electrician. All boxes are different. All of them require maybe a different interlock plate. We let the master electrician determine exactly what plate UL listed that allows you to safely backfeed your power back through your electrical distribution or your breaker box. That being said, the reason for this is that should you backfeed power to your breaker box and for some reason you don't have the ability to interlock this main breaker out, you can ultimately send power back through the electric power lines. It would not only go to your house, but it would bleed back into upstream to the power lines and could ultimately harm a lineman who's ultimately trying to restore power to your neighborhood. So this provides proof that you are doing it safely. Should any event happen, you are not the cause of having power going upstream of this breaker. So I'm going to turn, so this is how it happens. Right now I am on line power, so currently normal. Assume power goes out. Here's the operation. Power goes out. I want to put the generator on. So I want to be able to backfeed to this breaker here, but I cannot do it with it off. Basically, the electricity would stop right here inside the breaker. So to be able to allow it to backfeed and feed the electrical panel and distribute that throughout the whole system, we're going to pull this main breaker off. Now, the only way I can put the generator power on is by having the main breaker off, which allows me to push this plate up and then now put the generator power on. But you notice I cannot put the main breaker back on, hence never a risk of backfeeding up to the utility line. So line power comes back on. You now don't need the generator. You just reverse the process, turn that breaker of the generator off. You slide the panel down, and then you put the main breaker back on again, and power is restored to the house. So let's talk about this for a moment. This is a key component that I never even thought of when I contemplated the system. Was ultimately when my master electrician came in, he asked me if I should give consideration to having a whole house surge protector. And this was installed back in 2016 when I put this setup here in preparation for an emergency. But ultimately the whole house surge protector is one that allows, whether you do any of this at all or not, I strongly recommend you consider putting this in your home, because when you do this, the need for smaller surge protectors that you might have with your computer or with your TV to protect against surges is now protected by a very heavy duty surge protector that allows you to protect everything in your home from surges at any time. So at this point, right now, all my house is protected from dangerous surges. And at the flip side of this, when I put the power into this generator, from this generator, every now and then there'd be some uneven surges that come in that when I do put my generator power through this box, it goes through the surge, well, it goes through the breaker first and comes through the surge protector. So should there be any uneven power that comes into the house, this protects against your electronics from being damaged, sensitive electronics from being damaged. So this is the electrical part of it, and this is the magic of being able to fire everything in your house for this reason. So Chloe, follow me for a second. I'm going to show you something that and I want to explain this carefully here, is if you were to zoom in on this, and you may have done it earlier, Chloe, here's the meter for my generator that ultimately shows the amount of hours I've used this generator since 2009, which is 37.5 hours. At 37.5 hours, over 12 years, this is the use I've used this generator. That being said, I haven't fired it up for every single power outage, but when it would be an extended outage, I would use it. In this case, let's say we conservatively used it for every power outage, and we doubled and even added more to that to, let's say, 84 hours for the purposes of math sakes. In 12 years, you would use a generator like this for standby reasons for a maximum of, let's say, 7 hours. For 7 hours a year, you're faced with the decision of having a whole house generator at $10,000 to $12,000 investment, plus another $50 to $100 a month maintenance to keep a whole house generator working for you. Now, of course, that is the gold standard, but at the end of the day, most people don't want to spend that kind of money, and one can understand why when you're not using it, but upwards of a handful of hours a year. So that being said, this is the system I used that I felt I could practically get by with, because ultimately, this generator is not big enough to fire a whole house air conditioning compressor outside, but the way I did that cheaply is that I have an equivalent of a window unit that I use to fire up to my 110 outage. My 110 electric system that ultimately in my house, this generator can power to keep my master bedroom and master bath cool for me to sleep at night in the cases of an emergency. Now, this generator is, it's portable, it's a smaller unit, but ultimately during this winter storm, I was able to power everything that my home required to keep with the creature comforts of home. The only thing I couldn't fire, did not need my air conditioner, but the only thing I couldn't fire up were my pool pumps, which were on a 50 amp service. That being said, during this winter storm, we gratefully had all services needed, internet, TV, electricity. We were able to wash clothes, was able to dry. I have a gas dryer as a heat source. My furnace is natural gas, so I was able to run my furnace with the Nest thermostat as normal. Basically, we had all the creature comforts we would ever want. Just be a little careful, especially when using a small generator, not to fire up things like microwaves and things that are big energy hogs, like 2 or 3 blow dryers at the same time and stuff. because that puts a strain, especially on a small generator. Now, that being said, with the overwhelming response we've got so far, I'm very grateful for it. People are asking for an upsized version of this to be able to at least run one air conditioning unit outside of their house. And so on the way, we have a generator that I hope to demonstrate fairly soon that ultimately is 15,000 starting watts, 12,000 running watts, which will be able to run, from all calculations we've done, be able to run most homes, everything in the home, and maybe one air conditioning unit outside, which would keep one area or one room or one floor of your house comfortable during a storm.
How many watts is this one?
This generator is 6,200 watts, 8750 starting watts, but running watts is 6,200. Now, we'll get a lot of technocrats out there that'll tell you, you know, gas is of highest BTU value, so all of these generators are rated on gasoline. But at the end of the day, gasoline provides the highest number of output watts per the generator. Second highest is propane. Last is natural gas. Okay, so if you derate it based on the fuel that I'm using, the 6,200 running watts is more likely 5,000 watts actually going into the house. And even though we comfortably were able to survive the storm, and my stepdaughter was able to stay on the internet, we're all able to be comfortable over the 25 hours of power outage that we endured. So hopefully this is in some way helpful to folks who are unable to see the system or come by and actually see the system in person. It's going to spawn a lot more questions, no doubt. This will happen. I'm happy to answer them, but hopefully this gives you a picture of what I'm hoping to have been asked by dozens of people to replicate for their own homes, and appreciate the opportunity because and also this all happened very fast. It looks like this is going to be an LLC pretty quick, and I'm happy about that. And the name of the company, we project it to be Gen Xerator. I'm part of Gen X, so hopefully this is something that will be helpful to you when evaluating generator options. Feel free to message me on Nextdoor, Facebook, by email. A lot of you have my contact information. Feel free to message me at any time, and hopefully this answers some of your questions and gives you a picture of the system that I've been demoing to countless number of people. So again, many thanks. Wish you guys a great day, and take care.